All right, so I just want to fly through some of these density problems. And some of them are mass, some of them are volume. Really the key is looking at units here. So like right here I see cm cubed. Anytime I see cm cubed or mLs, I know that it's volume. So you don't have to do the little superscript, like that is fine. Over here the weight is 20 grams. As soon as I see the word grams, I know that it's weight or mass. So that leaves us to calculate for density. So just make sure you know how to use this triangle. So, here you have mass already, you have volume. That means you're searching for density. It's mass divided by volume. In this case, it would be 20 divided by 20, which would lead to a density of 1 gram per cm cubed, or you could write this as 1 gram per ml since they mean the same thing. Over here, this time I've given you the density. So I just get into the habit of filling in what I have, and then it tells me what I'm looking for. So cm cubed means that I have volume. So what is the mass? So if I'm looking for mass, it is density times volume. So I have these two, and I'm looking for this one. So in this case, it's 10 times 5 would give me 50, and then the unit is grams. So anytime I'm looking for mass is grams. So go ahead and fill out the rest of these. I can show you, again, pretty easily, what it is. So 0.5 grams per centimeter cubed, and then there's 40 grams, like that. This one here, it's a box, so before you put in volume, you got to calculate it. So 4 times 2 is 8, times 1 is 8, so the volume is 8 cm cubed, or 8 mLs. The weight is 12 grams. This one be careful with, don't leave it as a fraction. You'll have a decimal, works out to like 1.5 grams per centimeter cubed or something like that. Same thing here, look, you have volume here, you have mass, that means you're looking for density. Over here you have volume, you have mass, again you're looking for density. So it just depends on what variables you have. It leads to you finding the third thing. This link takes you to the simulation that you need. This one is pretty straightforward. And I got to relog in here. Hold on. There we go. So anything in yellow you answer. So, here's some basic questions right here. I think this is the one that people had trouble with. It says to pick up object 1 and to put it into the graduated cylinder. So let's go over here, object 1, drop it in. And what it's asking you is, it says, what is the initial water level? So it started off at 400 mLs. And then where does it go to? So if you come back, it goes to 414.2. So 414.2. What is the volume of the object? The volume of the object is always how much water it moved out of the way. So in this case, it is 14.2 mLs, like that. And I should put my units here as well. All right, how do you know if an object is going to sink or float? If the object is greater than 1 gram per centimeter cubed, it's going to sink. If it's less than 1 gram per centimeter cubed, it's going to float. Over here, these are very simple. So we already know the volume of object 1 is 14.2. Then we need the mass. That's pretty easy. Come back here, take it out, put it on the scale, makes that weird sound. And then put it in 19.5. Now look, since I have the units up here already, I don't need you to rewrite the units. And then from here, it's just calculating the density. So it works out to 1.35. And then again, it should be grams per ml or grams per centimeter cube. Is it going to sink or float? Well, since it's higher than 1, I'm just going to put an F here because, an S here, because it should sink because it is higher than 1 gram per centimeter cubed. And that's all you do. Take the next object, put it on the scale. You got to take the other one off. Okay, so don't put 2 objects on. So it's 11.1. Put it in here. mLs is 9.7. Take 11.1 divided by 9.7. It'll give you the density. Just make sure, like I said, you take the object off and then do the rest of them. Again, pretty straightforward. Okay, so get all the way up to object 12. And then tell me whether it sinks or floats. These right here, can you tell if it's going to float or sink based on mass alone? No, you can't, because you need the volume to figure out its density. Can you tell based on volume alone how big or small it is? No, because you need the mass in order to find the density. This one, people are asking about this. Don't worry about it. It's not in yellow, so you skip. What do you notice about the density of the floating objects? You should notice that they're all less than 1. What do you notice about the density of the sinking objects? You should notice that they're all greater than 1. And then this one, I'm going to let you answer on your own. So this is like, okay, what happens if the mass is bigger than the volume? How can you predict, or can you predict if it's going to sink or float?